Okay, so this is the second video on titrations, and in this video I'm going to focus on the titration calculations. So previously we've talked about titrations, we've talked about using them to make a salt. You initially make the salt in water, you evaporate the water, you're left with the pure salt. But you can also use titrations to find out the concentration of an unknown solution, and that's what we're going to be doing in this video. So I'm just going to briefly explain how that would work. So let's say I have got my acid and I have got my alkali, and let's say my acid, I'm going to say my acid is HCl, and let's say I know the concentration of my acid. So in the previous video we looked at concentration, and we saw that we have concentration in grams per decimeters cubed or moles per decimeters cubed. So in this case I'm going to use the unit moles per decimeters cubed. I'm going to say my HCl, I've got 0.1 moles per decimeters cubed, so I know that concentration. Then I've got my solution at the bottom of an alkali. I'll draw the arrow actually pointing at the alkali. So in my beaker here, I've got an alkali. Let's just say that's sodium hydroxide. That's my alkali. But I have no idea what concentration sodium hydroxide I have. When I carry out my titration, I'm going to be looking for that color change. And when I see the color change, again, I note the volume of HCl that I needed to add to get that color change. So let's just say I needed to add 23.0 centimeters cubed of my HCl in order to get a color change. And I know, because we place a known volume of alkali into the conical flask, I know I was starting off with 25 centimeters cubed of NaOH. Because I know the exact volume of this concentration of HCl that was required to neutralize my NaOH, I can use all of these values to figure out what concentration I must have. Okay? If you had a really concentrated solution of NaOH, you would be expecting a high volume of HCl to be required to neutralize it. If you had a really low low concentration of NaOH, you would have a much lower volume of HCl required to neutralize it. So you can use these values to calculate the concentration of NaOH if you don't know it. You would have to know the concentration of at least one of them. Okay, so you can have one unknown, but then the other one, it has to be a known concentration. And you can do it either way around. You could start off knowing the concentration of the NaOH, not knowing the HCl, and again, the volumes of both that were needed to react with each other, you can use those figures to calculate the unknown concentration. So we're going to have a look at exactly how you do this, and because I love a table, again, I do all of these calculations using a table. I want you to also use tables. It keeps things super clear and easy for me to mark, so that if you make a mistake and you don't get the right final answer, I can easily follow your working and give you credit for anything that you have done right. These calculation questions can be worth up to 5 marks, okay? They can be 3 or they can go the whole way up to 5. So really important that you're able to do them, and we're going to use a table just like we always do. Okay, so the kind of tricky thing about these questions is often they can give you a lot of information in the exam question, and we'll see that later on, okay? But for these first few examples, I've just given you the bare minimum information that you need, and we'll practice solving these equations, and then we'll look at the trickier exam questions where they tend to give you lots of information about the practical, and it can get a little bit overwhelming. Okay, so they are telling me, so it's really important here, when you're going through the question, you're going to see lots of numbers, all right? So I'm just going to highlight these numbers. I've got a 20 there, 26.3 there, and 2.5 there. I've got 3 numbers in my question. You're always going to be given 3, all right? You need to be comfortable what those numbers are. So you need to know what the units mean. So the first one is centimeters cubed. If it's centimeters cubed, then it is a volume. Centimeters cubed is a unit for volume. Over here, I've got another thing with the unit of centimeters cubed. So I've got another volume. And then the last number is followed by mole per decimeters cubed. That is the unit of concentration. So I've got two volumes and I've got a concentration, which is what, again, I said that you would have. Two volumes and a concentration. Use these three numbers to find out the fourth, which will be the other concentration. And then I construct my table, okay? I'm reacting sodium hydroxide with sulfuric acid. So you'll always have one acid and one alkali. So I've written my sodium hydroxide and my H2SO4, my sulfuric acid. In the other table, we had mass, formula mass, and moles. Now we've got volume, we've got concentration, but we do still have moles. So it's volume, concentration, moles, and then again at the end, we've got ratio. So these two are different than what we've seen before. With the NaOH, I am given the volume. It says 20 centimeters cubed of an unknown concentration of sodium hydroxide. So I have a volume of sodium hydroxide, 20 centimeters cubed. However, if I look at my units for concentration, they're in decimeters cubed. And the first step in these calculations is always to change your volumes from centimeters cubed to decimeters cubed. And I think I've written it on all of the questions. Change the volume from centimeters cubed to decimeters cubed. So I'm given 20 centimeters cubed. I divide by 1000 to convert that to decimeters cubed. I'm also given a volume for sulfuric acid. So it's titrated against this volume and this concentration of sulfuric acid. So this is my volume of sulfuric acid. So I put that into my table. Again, it's in centimeters cubed. I divide by 1000 to convert to decimeters cubed. And just doing that unit conversion is going to get you a mark. The concentration that I'm given relates to the sulfuric acid. The sodium hydroxide is unknown. The sulfuric acid is 2.5 moles per decimeters cubed. And I can just slot that straight in because now the units I've got for concentration matches the units I've got for volume. They're both in decimeters cubed. So I fill that in. I can also fill in the ratio, again, exactly the same as I always did. So the large number in front of NaOH is 2. The large number in front of H2SO4 is 1. So I fill in all of that information and now I need to find moles. So you can see over here that with NaOH I don't have enough information to find moles, but with H2SO4 I do. But I don't have mass and formula mass, I've got volume and concentration. So how do I use those two quantities to find moles? And it goes back to the video I did on concentration and I showed you this other formula triangle. And we can see from the formula triangle that if I cover moles, I'm left with concentration times volume. So you've got moles at the top, you've got concentration and volume at the bottom. And that is the formula triangle that you are going to be using throughout all of these calculations. I'm just going to write it here. Moles is at the top, volume and concentration are at the bottom. So if I'm trying to find moles, it's going to be volume times concentration. So my volume is 0.0263. My concentration is 2.50. So I'm going to multiply those two together to find my number of moles. 0.0263 times 2.50. And I end up with 0.06575. And I'm not going to round it just yet. I'm going to keep it nice and accurate. And then I use my ratio just like I've always done. Ratio is 1:2. So I need double the moles of NaOH. So I take the moles of H2SO4, my 0.06575, and I multiply them by 2. And when I do that, I get 0.1315. So now I've got my moles of NaOH. And I want to find my concentration of NaOH. That is what I'm trying to find. How do I find concentration? Well, using my formula triangle, I cover concentration because that's what I'm interested in. And I'm left with moles divided by volume. So my moles I've just calculated as 0.1315. My volume is 0.02. So I divide by 0.02. And I get an answer of 6.575. And I haven't told you in terms of decimal places, but because you're given the others to one decimal place, I would give this probably to 1 decimal place as well and round it up to 6.8, but you'll be told that in the question, okay? And that is your final answer, okay? You know how much, you know the concentration of your sulfuric acid, you know exactly what volumes were required of your acid and your alkali. You can then find the concentration of your alkali, okay? These are all done exactly the same way. So if we have a look at another one, I would say pause and do this one for yourself, and then press play when you're ready to see the answer, and then you'll know for sure that you have got it. So press pause now and have a go at doing it yourself. The kind of tricky thing is just reading the sentence and making sure you're matching up the right numbers with the acid and the alkali. But press pause and have a go at that for yourself, and then press play. Okay, so I am just going to do it from scratch rather than having it all filled in for you. So again, I have got 3 numbers in your question. You're always going to have 3 numbers, 1, 2, and 3. Again, the first thing I'm going to do is look at what these numbers are. So centimeters cubed, I've got a volume. Centimeters cubed, I've got a volume. Now I've got a concentration. The 25 is about the sulfuric acid. So this time it's the acid. 25 centimeters cubed of unknown concentration of sulfuric acid. So I've got my H2SO4. I know the volume. It's 25 centimeters cubed. And again, I need to convert that into decimeters cubed. So it's going to be 0.025 decimeters cubed. You always have to convert. The other volume, 13, relates to is titrated against this volume of sodium hydroxide. So that 13 relates to the sodium hydroxide. So again, I divide that by 1000 and I get my volume in decimeters cubed for NaOH. I've also got my concentration for NaOH, 1.80. I can fill in my ratio as well. I've got a big 2 in front of NaOH. I've got nothing in front of H2SO4, so it's going to be 2:1. To find my moles when I've got volume and concentration, remember, cover moles, I'm going to have to volume times concentration. So it's going to be 0.013 times 1.80. So I do 0.013 times 1.80. And I get 0.0234. 2:1 ratio, but I need my NaOH to be twice my H2SO4, so this needs to be 2 times smaller. So I'm going to be dividing by 2 this time. I divide that by 2, and I'm getting 0.0117. Now I've got my moles. I need to find my concentration. Again, if I've got moles and I've got volume and I want concentration, it's going to be moles divided by volume. So really important you know that formula triangle. You can't do this without it. So it's going to be moles, which is 0.0117 divided by volume, 0.025. And I end up with 0.468. And that's going to be my concentration in moles per decimeters cubed. Okay? So they are all done exactly the same way. So I get you to do number 3 yourself. Actually, press pause and do number 3 yourself, and make sure you can do it, and then press play when you are ready to see the answer. Okay, so I've already filled that one in. Again, make sure you convert your volumes to decimeters cubed. So the 22 relates to the potassium hydroxide. Divide by 1000. The 17.5 is the sulfuric acid. Divide by 1000. That's the concentration for the sulfuric acid. Once you've got your volume and your concentration, you can find moles. You're multiplying those 2 figures together, and then you can use your ratio to find the moles of KOH. Then you've got volume, you've got moles, you just need concentration, and it's going to be moles divided by volume, and you get your answer for KOH, okay? So they're all done the same way. So I've given you a couple of practice questions. So this is what you're going to be doing in lessons. So yeah, just make sure, my main advice is read the question, make sure you have changed your units, and make sure that you assign the right volumes to the right reactants. Okay, so read the sentences carefully and know which one you're talking about. I've made 4 and 5 a little bit trickier. I just got you to use some of what you did in the concentration video. So rather than telling you the concentration of the sodium hydroxide, I want you to work it out. So I've given you the mass and I've given you the volume, and I want you to use that information to find the concentration of sodium hydroxide in moles per decimeters cubed. So you'll have to take the mass, divide by formula mass to find the moles, and then take the volume in centimeters cubed and divide by 1,000 to find the volume in decimeters cubed. Once you've got the moles and you've got the volume in decimeters cubed, you can find the concentration. And then once you've done that, you've got the concentration of the sodium hydroxide, you've got the volume of the sodium hydroxide, and you've got the volume of the acid, and you're just finding the concentration of the acid using the table as you did in 1, 2, and 3. In number 5, I do something similar. Again, I ask you to use what you learned in the previous video. Work out the concentration of lithium hydroxide for yourself. You then find the concentration of lithium hydroxide. You've got the volume of the lithium hydroxide. You've got the volume of the acid. And then you draw the table to work out the concentration of the acid. So it's combining 2 different pieces of knowledge. The next little bit is about concordance, and this is just what I was talking about before with accurate titers. So each time you do a titration, it's called a titer, and you have to get accurate results that are in, I should be written precise there, precise results within 0.1 centimeters cubed of each other. So this is my first one. This is my rough titer, 24.8, and then I do it another 3 times, and I see I've got 25.3, 22.1, and 25.2. So I'm not going to be using titer 3. It's not within 0.1 of titer 2 and 4. But I will use titer 2 and 4, and I will average them. So I'm going to be ignoring titer 1, okay, because it's my rough one. And then of the remaining 3, only titer 2 and titer 4 are within 0.1. So I've got 25.3, 25.2. They're within 0.1. 22.1 is way off. So I'm not going to use it. I just get the average of those 2. And that's going to be my accurate volume. So sometimes they will get you to do that in the exam question. This is when they tend to give you lots of information. So these are some examples of some exam questions. So they just write lots of information, just makes it seem harder than it is, but it's not, okay, I promise you. So it says a student used a pipette to add 25 centimeters cubed. So I said a pipette was that accurate piece of glassware that allows you to measure the volume of your alkali before you put it in your conical flask. And you're given the volume there. Unknown concentration, that's what you're trying to find out. The student then does the titration. They give you the concentration of the acid. But instead of just giving you the volume of the acid required, they give you all of the different titration results, and they want you to pick out the precise results and get the average. So again, I'm going to be ignoring titration 1 because that's my rough, and then I'm looking at 2, 3, 4, and 5, which ones are within 0.1 of each other. So I've got 2 here at the end that are exactly the same, and then I've got this one, 27.05, that's also within 0.1. So I'm going to be averaging these 3, 4, and 5, and I'm going to be ignoring 2 because it's not close enough. So you're going to have to get the average of those 3. That gives you the volume of the acid. You've already got the concentration of the acid. You've got the volume of the alkali. You're then, in part B, going to draw the table exactly as we've been doing, giving your answer to 3 significant figures. Then what they do is they give you another experiment, blah, 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 calculate the mass of sodium hydroxide. So what they've done is they've given you the volume of sodium hydroxide and they've given you the concentration, and they want you to find mass. Okay, so there are 2 triangles that you need to know. You've got the one with moles, concentration, and volume, and you've got the other one with mass, formula mass, and moles. And you will see that moles is the only thing that is common to both of those formula triangles. So in this question here, you're given a volume and you're given a concentration. because you're given two things from this triangle, this is the triangle that you're going to be using. You've got your volume, you've got your concentration, you're going to multiply them and you're going to find moles. Once you've got moles, you can then come over here, you can find out the formula mass, as the same way we always do, using the numbers from the periodic table, and you can multiply moles by formula mass to get mass, which is what you are asked for. So anytime they give you one of these questions, where they give you some numbers and then they ask you for, a specific unit, write down these two triangles, see which triangle you can use first. In this case, you've got concentration, you've got volume, multiply them, find moles. Once you've got moles, you then got the two things you need in this triangle to find mass, which is what you are asking for. And there's a couple more examples of where you need to use both of those triangles below. So yeah, some of those questions there can be a little bit tricky, but again, you can mark your work as you go. I've got all of the answers for you here at the back, so I've drawn out all the tables for you. The answers I've got in bold are the answers that you need to be able to work out. And then on those slightly harder questions, again, I'll try and make it clear. I work it all out for you. There's a few questions, general questions on strong and weak acids as well. So, I've written all the answers for you, but hopefully you remember some of it from CC8. Again, so that's 2 videos now on just titrations. Titrations, when you get to the exam questions at the end, you'll see that they are the biggest part of this topic and are definitely worth your attention. So I know they're also the hardest part of this topic. So if you're going through the questions in class and you're getting them wrong and you can't see where you're going wrong after checking my answers, then please do drop me a message. I will help you out.